So this is our presentation. This is the next generation delivery system. We're designing this because it meets a very important societal need. Go ahead.
So let's just start with the key metrics. According to ADA Transportation Company, only the urban cities in USA has like a delivery system worth of like 500 billion USD alone. That's like just the USA alone. The world is gonna be like in trillion. So let me start with like how much is like the Houston worth. The delivery market of Houston is worth like $5 to $10 billion. And 66.5% of the customer which shop online are like through big chains like Walmart are trying to they need their stuff like in one-day delivery system, but the Walmart is like cannot do it for free. It is costing them like $4 to $5 to deliver their stuff. So everyone wants like, because of the Amazon, everyone wants to have like the free delivery system, but they don't want to pay more like $5 or $10. So what we have come up with, like we have come up with a solution to this problem. Francis is going to discuss the problem.
Yes, the biggest problem that we have right now is that there are many logistical problems just delivering basic goods in urban centers. Obviously, one of the biggest problems is traffic. The other problem is that most delivering systems are not reliable anymore. And furthermore, with less reliability comes an increase in cost and profit efficiency. So this is, which is also leading to global warming because we can't have any more fossil fuel vehicles on the road anymore. So this is why, and the final thing is that most delivery systems are not adequate during disaster relief operations. So this is why we designed this system.
So to overcome this solution, we have like designed two main parts. One is the command center. So this is how it looks. So you have like a whole command center. This is like the motherboard. This is like the battery changing operation. So we already 3D printed and designed the drone. This drone is going to land on the landing station, and then this thing, the command center, is going to move its hand and change the battery. So this whole system is going to be a beehive. If you have like 5 delivery drones, you can have like 5 landing stations. If you have like 7 or 8 landing drones, you can add like more landing stones. This is like more like Lego puzzle. The more drone you have, like you can easily add like landing station. You don't have to like add like whole complete system in this. And now the Francis will go.
See, now this is the next command center picture.
Yeah, this is
now the drone. We've been working very hard to complete this drone. The drone is equipped with multiple apparatus. Each one, either right now they're basically being operated by human, but the whole goal is then to apply machine learning and apply AI in order to be able to have the system be able to basically to automate the system completely, so human interaction is not necessary. But the apparatus are very flexible. They can be designed to meet any setting or any need. This is a prototype of an apparatus we built.
So this is how it works. Like imagine this is like this drone. This is gonna be mounted on the drone like this. So the drone is gonna land and like it's gonna grab the object like this. This is like the closing radius. So there is like a difference between like opening 3 inches to 5 inches distance between the closing and the entering radius. So you can see like this. It lands there easily, it closes its pin, and like it's grabbed the object and then it flies away. So this is like one of the apparatus. The other is like so the apparatus goes like this point. So you can easily mount like cameras here, you can easily mount whatever you need. In time of disaster, as Francis suggested, we can add like thermal camera to see like where if people are trapped under the building, because thermal camera are the most reliable thing that like we can use in like a disaster time.
And that would have been very useful, for example, during the TLC fire that recently happened.
Yeah.
Now, unfortunately, due to time limitations, we did not have enough time to prototype the command center. We did have enough time to just design it, to design the command center. But we did actually prototype, we designed, we prototyped, and we built the drone.
And the flying videos of the drone would be a separate one. We have like on the YouTube channel, but we're going to add the link to it.
Yes. Now, this is how the system works.
So imagine Walmart has 2 different locations, and you have ordered like a toothpaste that you fancy. It's either like a Game of Thrones style toothbrush or any other you like. So this is the location where the toothbrush is. But the problem is the drone has only the battery to like go to this delivery station, but not to come back. So this is what the drone is gonna do. It's gonna go to this delivery location, then it's gonna look around like for closer charging station. Then it's gonna go to like, it's gonna look like there's like just a like 1 mile away, like another store of Walmart, it has a command center. Then the drone is gonna fly to the second location and it's gonna change its battery. Then like the operator there can decide if it wants to send the drone back or wants to do another delivery with the drone. This whole thing is gonna happen like in less than, the battery is gonna be changed in less than 2 minutes. So in less than 2 minutes, you're gonna have like a drone operational. So this is how we can like continuously keep sending the drone without like having it like charge the whole battery and stay there. This is how we can save more time and deliver more stuff. And as all this is like, we are using electricity, we can add solar panels there too. So like, it's all gonna be like the cheapest delivery system like all over Houston.
And furthermore, this example is just showing basically a simple example using 2 stores. In an urban setting like Houston, we would have multiple stores. Obviously, with multiple stores, we would be designing a greedy algorithm to optimize the routing for each drone. That way, we're basically making sure that every drone is able to get battery quickly enough. And more importantly, products can be delivered quickly and we avoid any accidents. So that is another step of the programming that we're going to be completing. Here's another, this is a bigger, so you can see of our scenario. And this is basically a mechanism to prevent, this is a mechanism to put on top of the command center during the rainy weather, which happens all the time in Houston.
So this is like how it worked. So this is like, imagine this is like an umbrella, U-shaped umbrella. So whenever it's gonna be rain or hailstorm or any like disaster event, so this thing is gonna be completely closed and like the whole system is gonna be safe inside this like whole umbrella. So when like the disaster is over, this thing is gonna be reopened and the drone can like easily start the delivery system. Compared to the road-based system, you cannot, the road-based system won't work for like 3 or 5 years. Our system could be easily operable soon after the disaster. So this is why this is better than the road-based delivery system.
And this is our first business plan.
So we can like generate money by selling the command center and the drone to different like buyers. Like Walmart has great need for this, McDonald's has great need, and all of the best, CVS. Because like there are a lot of like old people who cannot visit CVS and cannot afford to like send a person there. So what CVS can do, they can charge like a 50-cent delivery to like the old people. They can like have their like supplies delivered to them at their doorstep, so no one has to leave their home. Because like the medical supply in the time of disaster are the most prominent one. So CVS can like supply the medical supply to your home without like having any like flood problem. They can go to areas where like normal like systems cannot go, like a car or fire truck. So this is one of the system. The other system is Francis going to talk about it. This is project.
Yes, the other business plan is basically to lease the rooftops of private stores in different locations of Houston, installing our system there, and taking orders of a delivery through an app. There's approximately 10,000 to 15,000 privately owned stores all over Houston. Now we can remember that most of the stores, the floors are being commoditized. But with this business plan, we're basically disrupting the whole industry by using the roofs now. We're basically placing a value on the roofs of different private properties, and we're basically installing our system. A command center in every 2 to 3 miles of radius would simply require only 200 stores, which we would cover most of urban Houston. And then we can allow for basically fast, effective delivery between any location. So we would be basically, for one delivery in a radius of 5 miles, we would be charging them about $1. So this would be significantly cheaper than any other company would be significantly cheaper than Amazon or Walmart at the moment. And who would want to buy our product?
As like Francis and I discussed, like Walmart, McDonald's, and other people like are interested in this system, because like again they want to have like an effective delivery system which doesn't like damage like our environment. The one that like are reusing like the car-based system, like most of them are like with petrol. So as you know, we are like the natural disaster has like increased like by 2019. The amount of natural disasters like 5 times compared to like 10 years. So this is why like this is all gonna be all electrical and it's gonna be eco-friendly. So this is the one main important reason why they want to have this. And the other is like reusability. You can like just like change the battery and you can like have it fly. So, and like as like FedEx, like I can give like small example of FedEx here. So last year FedEx reported 15 to 20% of their shipments got stolen from people's home. So with this system, they can set their own time, at what time they want their system, their thing to be delivered. So right, for example, you came back home from 8 a.m., 8 p.m. So you're gonna set a time of 8 p.m. The drone is gonna be there at 8 p.m. So this is like the beauty of this product. Last part.
How can the system help society? Well, last year, Hurricane Harvey taught us many valuable lessons. One of the most important was that our traditional relief transportation system is useless for 2 to 4 weeks after the natural disaster. This is why this is the main reason that the damages of Harvey cost in the sum of $110 billion. Most effects are usually felt after the disaster. However, our system is estimated to reduce the cost by half. If our system covers all of Houston, then soon after disasters like Harvey, we can deliver medicine, food in less than 30 minutes all over Houston. Obviously the time will vary from location to location. The best part of our system is that it can deliver medicine and other supplies to disaster-affected area in less time than any other mean that's being used right now. And the whole infrastructure would already be in place and is weather protected. So there's no way that our system can be handicapped or can be affected by a natural disaster.
Okay, in the last, I would like to tell you why this is better than the land-based delivery system. So you have like a dozen of companies that are working on autonomous land-based delivery system. But I would like to tell you that that system is really slow. And we do not know like there are like many problems with the traffic like human. You know what kind of drivers humans are. I don't have to tell you. So like that system is not reliable for us. We don't have the infrastructure to add more autonomous car because like this is gonna like overflow the traffic and like as we live in Houston, we know what hell a traffic is. So our system can reduce would not like affect the traffic or anything. The traffic would be reduced with our system because like all like the big transportation and small transportation would be like eliminated by this. And that we can add more jobs with this system because like you're gonna train more technicians in a new field that those are gonna be like drone operators and new machine learning style for them. So it's gonna also create more jobs for the community. And the last, as we already tell, disaster. We have been through like Harvey. We know what it's like to live in a disaster. So we want to help people in time of disaster. We don't want to like have like property damage because like people cannot afford, like poor people like us cannot afford like more property damage and stuff like that. So this is like our main priority, disaster and like cheaper delivery system. That's it. My name is Jassim, and this is my friend Francisco. He's gonna let
Francisco. And the whole total cost of the system would take about $10,000 to $15,000 to complete the system. The drone, each drone is going to take about 1,000 or 1,500. Obviously, that's the first iteration. As we proceed to the third, fourth, fifth iteration, the prices would considerably come down. And we do hope to have the drone completely manufactured in the U.S.
Yeah. And this is a small example how you can use in a border security. So this is like, imagine you have like 3 command center on the border. These are the radius of each command center. So like someone tried to smuggle some drug or something like in US through border, these drones are gonna be there for 24/7, like guarding the border, which like border patrol cannot do it right now because like they're human, they cannot be everywhere. So what we design is like we plan like we're gonna have like three drones in a radio. First one is gonna fly to the defense radio. When his battery is gonna run out, it's gonna like we're gonna send the other drone. Till the other drone doesn't come here, the first drone is not gonna leave. When the drone is here, the second drone is gonna go there and it's gonna like recharge and be there for like the delivery. So this is like our
This is just another final small example to show the adaptability of our system.
yeah,
So
in
this
multiple industries.
So this is our system. My name is Francisco.
My name is Jassim, so we are like the advanced drone delivery system guys. Thank you.
Thank you.